Enthusiasts. After a long procrastination, I have finally been able to come and muster up enough enthusiasm to make a video that I had promised in my last video about the handmade water pump or DIY hand pump. With me, I have my junior science enthusiast, my son Pratham.
Hello.
Yeah. Together we'll try to explain you how we'll explain two things. Firstly, how a hand pump is made at home, and then secondly, I will try to explain the physics behind the hand pumps. So, without any further ado, let's get started. So, Prabha, can you hold this for a second? Alright. So, what we have here is a homemade hand pump. What we have here is a 60 ml syringe that you can get at any pharmacy store or any hospital or dispensary. Make sure if it's a used one, you wash it properly. Then we have a funnel. We just have a reservoir which is filled with water here. This is a homemade contraption to gain leverage. I mean, this is not absolutely necessary, but this is just made to make this toy or project close to real life. This is nothing but aluminum rod that I got from a old antenna up on my terrace. This is a plunger. Now what we have done is we have done two modifications to this syringe. I have a cross section right here. This is a cut section. So the modifications we have done is we have drilled a hole into this plunger. You can see here there is a little hole up here, and then this one. This hole is here to let this balls rest, and also we have removed the seat of the plunger so as to make it a flat edge here. Usually this 60 ml syringe have a convex surface or a seal. We have kind of sliced a little bit to make this flat. Okay, so this is your cross section. This is how it looks. Now in today's video, what we'll try to do also, we'll try to explain as we speak three functions. One is a priming, one is a non-return wall concept, and another is a siphon effect. But before we get there, I'll ask my junior scientist here to do some demonstration of how this thing works. So he'll start first with priming. So what he does is he's basically putting water into the syringe, which is empty right now, to prime this up. And now he's going to start showing you the operations. Here you go. As you can see, the water is now started gushing out of the spigot, just the way real life would. Thank you, person. That should do it. Just for the sake of showing you how this is made, what we have done here is we have got this tin metal strips here from a local tin maker, which comes very cheap. For me, it only cost around 5 rupees. And then I have drilled holes here. Can you come a little closer? I have drilled holes here so that this aluminum rod gets as per this leverage pattern here. This is your fulcrum here. This is the fulcrum, this is the pivot, and then it kind of pivots around it. Now you may argue that you don't need this. Yeah, you don't need it because you can pull this up with hand, but then it's not as attractive as it is right now. Okay, alright, so that's how it's made. Two holes drilled here, basically one for the funnel and one for the syringe to go in, and then there's a pipe that goes inside just to make sure that the groundwater is pulled up here. Now this arrangement is done so the water stays in a closed system. You don't have to keep constantly moving the water out and in. It just keeps circulating. Alright, as you can see, the length of this bar can be adjusted according to your requirement, but right now I can say it's kind of close to a feet. It's a feet long bar, and it gives you sufficient leverage. If you have it shorter, then you will find it difficult to move the plunger up and down. If it's too long, then it kind of impacts the stability. So I found it's a feet long length is an optimum length. Alright, as we saw the demonstration, now let's try to explain the concept. So the first thing, as you saw Pratham do, is priming. Now what is priming? Why didn't Pratham run the pump directly as the way it is set up here? Now what it does is, if we didn't, priming is basically an act of putting external water into the top chamber of the pump. If we didn't do it, then there was no way for these non-return walls to stay in place and the air would escape, and thereby there would be no negative pressure that is required. Now we just spoke about another concept here called as non-return wall. Now what is a non-return wall? For those who are not engineers, for those who are engineers will already know it, but for the ones who are not engineers, let me try to explain it. A non-return wall is a wall that operates in only one direction. We have made a homemade version of a non-return wall here. You see these small ball bearings that you can get at any cycle shop? This ball bearing acts or close the hole based on gravity. Okay, so it will only allow the water to go from bottom and to the top. It would not allow the water to go back down, because if the water tries to go back down, because of the vortex effect, this ball is going to go and jam shut into the hole there, thereby only allowing unidirectional flow of water, and which is why, since it doesn't allow returning back, it's called a non-return wall. Similarly here you have another one here. All right, so we have in total two sets of non-return wall, the one down here and the one down here. When you prime it, what it does is this water kind of goes and locks itself in this upper chamber and closes these two non-return walls shut. Alright, and then when we pull the plunger, when you pull this plunger up with these two walls shut, you are now creating a negative pressure here. Because if this non-return walls are closed, there is no way for the air to escape, and thereby you create a negative pressure here. The moment a negative pressure is created here, water from the groundwater table will of course rush, and that's called a siphon effect. Okay, siphon effect is when you create a negative pressure, the water or incompressible fluid will get pulled up into the direction of low pressure area. Now, because this wall here is again a non-return wall, it allows the water to get in and thereby filling this lower plunger, lower chamber below the plunger with water. So we have solved one out of the two problems. There are two problems, right? Firstly, we have to get the groundwater into this barrel, and the second problem is to get the water from this barrel out for our uses. So we have solved the first problem, that is get the groundwater from below into the barrel or into the pump, which is what we have done, and we achieved that by priming as well as this non-return wall. Now getting back as to how do we get this water that is in this lower chamber out from the spigot. To get to the spigot, it has to first come from the lower chamber into the upper chamber, and this is where now you start applying the downstroke on the plunger. When you apply the downstroke on the plunger, the water of course will shut this non-return wall close, so it will not escape below again from the path that it came. It's kind of a very smart entrapment mechanism. And because it's incompressible, so it has to go somewhere, you can't compress water, so it's going to put a force on the upper non-return wall, thereby raising those two ball bearings into air or or floating them, and water will start gushing through the holes that are cut into this plunger. So we achieved part of the second problem, which is getting the water from the lower chamber through these non-return walls into the upper chamber. But still, our final problem, the final part is not solved, that the water hasn't come out of the spigot. Now that's very simple. The moment you get it into the upper chamber, you pull the plunger up again, as Pratham showed you, and then the water now starts flowing out of the spigot the moment it reaches the level of the spigot opening. So this then process continues again, because when you pull the plunger up, this non-return wall opens up again, letting fresh water in here, whereas exhausting or sending out the water from the upper chamber. And so this kind of continues. Now, do we have to prime it every time? No, because the moment we prime it the first time, the negative pressure is already created. Unless there is a leakage in the pipes here or in the lower chamber or in the groundwater pipe, you don't have to prime this again. So it's the first time. That's why when you see the hand pumps in real life, you don't see them getting primed over and over again. It's just one-time activity, and it kind of continues again and again. The success of this mechanism depends on two things primarily. Of course, needless to say, you have to have water down below. You can't pump it dry. But the success primarily depends on two things. One is the sealing between this plunger and the chamber. The sealing has to be really tight and good. And the second thing is the selection of these balls that close the non-return wall. the bigger the hole and the bigger the non-return wall, the quicker and the higher amount of water that's going to flow out. But then you see water splitting. If you like this video, leave comments below into the comment section, and if you're not subscribed, please subscribe and hit the bell icon as everyone else says, so that you get a lot of reviews about my videos. The next video that I'll probably make is about Galton board, so stay tuned to see that video. Thank you very much and enjoy physics. Bye bye.